All right, in this video, we're going to address how to address quadratic inequalities and how to solve them. It gets a little bit tricky only because we're considering an inequality, but we're also considering a problem that should have two answers should it have been an equation. And so we have to deal with that whole plus or minus and kind of interval idea. So the first thing that we want to do is figure out our edges. And by that I mean, when would we be exactly equal to zero if you have a quadratic equation equal to zero here? So we can start that off by either factoring or using the quadratic formula, or really any method that we like in order to take advantage of where those points would be. And so since that -4 is out here, I would say the quadratic formula is probably a pretty good idea. So let's go ahead and just set that up, since we're already set in here with a, b, and c in standard form, where we can say that -b plus or minus the square root of b squared, again -1 squared, minus 4 times a times c all over 2a, so -8. Let's go ahead and clean that up a little bit. So -4 times -4 would be positive 16 times 3 is 48. 1 plus 48 then would be 49. So 1 plus this plus or minus the square root of 49 over -8. And with that being the case, 1 plus or minus 7 then over -8 gives us answers of 1 plus 7 would be 8 over 8, so -1. Or 1 minus 7 would be -6 over -8, being 3/4. So what we have there is, remember we're only working on one variable, so we have the idea that on a number line, somewhere between -1 and 3/4, we're either between there, where our function would be less than 0, or we could be beyond those two numbers. So, because the big idea is we're at those two numbers, that's where we're exactly 0. If we think in 3 dimensions, thinking about a graphing idea, what we're essentially saying is, if we drew in a y-axis here, we've got a parabola opening downwards, notice -4 x squared, so that's going to kind of swing up and down this way, which means that everywhere between those two numbers we're going to be above the x-axis, and everywhere to the right or to the left we're going to be below the x-axis. Plugging in an x value will get us back an output that will either be positive or negative. Now, considering our inequality, we want our expression to be less than 0. So we really want to include everywhere that's below, note over here and over here, below the x-axis, or where essentially we are less than or equal to 0. Well, that means that our answer should exist anywhere that x is less than or equal, because we are okay with being equal to 0, but less than or equal to -1, or anywhere that x would be greater than or equal to 3/4. And that's a great way to solve a quadratic inequality. Another option would be using intervals. Rather than looking at the graph, we could actually just physically plug in some numbers. Remember that those 2 points we found are the zeros, so they're where we're crossing from positive to negative or from negative to positive, which means if we would have plugged in any point in between those two, such as 0, -4 times 0 squared minus 0 plus 3, well, we essentially get positive 3. And since we don't want positive numbers, right, so not less than or equal to 0, then this, in between everywhere here, we're positive, which means we want everywhere that's negative. We want all those red lines. Now, why in the real world would we use something like this? Well, what if we ask you this question? The Sydney Harbour Bridge in Sydney, Australia, can be modeled by a nice quadratic function. You notice down here at the bottom. The actual driving lanes of the bridge are 52 meters above the water. So what we want to know is, what's the expanse for what horizontal distance x is the arch above the road? So notice as this arch goes, we want to know from here to here, when are we above the road? Well, we can obviously see from the picture, and the fact that this again is a -x squared, that we're going to be above the road everywhere in between these two lines. But what we need to know is where are the exact points so that we can find the distance between them. Well, all we have to do then is figure out for that function when we're 52 meters high, so at 52 equal to our expression, when are we exactly at those places? And if we know that, we can figure out the distance between them. Well, let's go ahead and subtract that over so that we're equal to 0, because we like to be equal to 0 when we're solving quadratics. Then we can take advantage of our calculator if we like. Let's go ahead and open up a new page here. And why don't we go ahead and just use our polynomial root finder. So menu, 3, poly tools, 1, and I'm solving a quadratic. So we're going to go ahead and press enter because we know it should be a real number, hopefully. And I'm going to put in my three numbers, my A, my B, and my C. A being negative 0.0021, negative 0.0021. Go ahead and hit tab. Then we're going to put in 1.06, 1.06, and a negative 52. And then go ahead and hit enter. Make sure it looks all correct in your expression. And when we press enter, you'll notice we get from 55.063. So I'm going to go ahead and write that down. So this was at 55.063 all the way up to 449.699. So 449.699. And remember, we want to know what the horizontal distance is. So basically the space between, because that's where we're above the road according to our picture. So let's go ahead and take 449.699 minus 55.063. And we'll do that very quickly here. I'm not sure if it will let me highlight just part of this, but if it will, that would be great. Minus. Go ahead and use our shift here. And when you hit enter, we find out that we are 394.635. So 394.635, and we're operating in meters. And there's our answer. I hope that helps you understand how we use quadratic inequalities. Good luck and have fun.